Hi, Jeff again, doing another one of my little how-to videos. This one's going to go over servicing wheel bearings and cleaning up and adjusting brakes on trailers with electric drum brakes. I think we'll break this into a couple parts. The first section will go over generally how electric brakes operate and the materials and supplies and tools, whatnot you'll need to clean them up. And the second video will actually go through taking them apart and what we're doing to service it. Basically, Dexter and Alco are the two major manufacturers of the electric brake axles that you'll find on RVs and utility trailers and that kind of stuff. I think both of them recommend like a 6-month service interval, which is way too often. I think most people service these about every year. And then a lot of people don't service them at all until they dry up and seize and the wheel bearing spins on the axle, welds itself to the spindle and leaves them stranded someplace. So kind of a messy job, a little bit time consuming, but it's sure a lot easier to service trailer brakes in your shop or in your yard or whatever than it is alongside the road after they've wrecked themselves. So I guess to begin with, we'll talk about the wheel bearings in these. Are a tapered Timken type bearing. The rollers themselves and the inner race and the cage are all one assembly. And the outer race, of course this is for a larger bearing, the outer race is a separate part. It's also worth noting that the outer race can be different part numbers of outer race can fit the same wheel bearing, having a different exterior diameter. So basically you've got a bigger tapered Timken and a grease seal down against the shoulder on the spindle of the axle. On the other side of the hub you've got another outside race and a smaller Timken bearing, and the end play of that assembly is controlled with a castellated nut and a cotter pin and a washer, and you're looking for about 1/1000th of an inch to maybe 3/1000ths of an inch of end play, or about where you can just barely feel it move. Larger heavy-duty trailer axles will run in 90-weight gear oil. These lighter ones will run in grease. I like to use something with the NLGI rating GCLB. That symbol right there. Basically that means it meets the highest standard of the National Lubricating Grease Institute standard for both wheel bearing application and for chassis lube. Not all greases rated for wheel bearing use also meet the chassis lube requirement. A lot of people seem to think wheel bearing grease means better, but chassis application is different. Tie rods and U-joints and stuff like that generally don't get hot enough to drive off moisture, and they're generally not as well sealed as wheel bearings, so they have a higher standard of corrosion resistance. And trailers tend to sit for long periods of time, get condensation in them and that sort of thing, which is, or the grease will separate, which is part of the reason I think they've got a more frequent service interval than the old when cars used to have similar wheel bearings on their front axle. So anyway, that's the wheel bearing assembly, correct kind of grease. Anytime you do one of these, I'd highly recommend you replace the grease seal. It's just not worth reusing. Could let grease leak into your brake assembly, which just isn't good. So kind of a false savings in my opinion anyway to try to reuse those. So let's look at the brake assembly. This is heavier, of course, than what those little wheel bearings are designed to handle. Anyway, what you've got here is basically an electromagnet on a bit of a swivel. It's held by a cross pin there onto this arm. Wires for the magnet are clipped along this arm and just come out the back of the back plate here. So how this operates, as the wheel's turning, there's of course the drum surface for the brake and a flat machined disc surface called an armature. As power is applied to this magnet, it clings to that armature, and that tends to pull it back. You can see that forces the leading shoe into the drum, which is then pushes the pivot basically and pushes the trailing shoe also into the drum, and that applies your braking power. You've got typical hold down springs and a cross spring here, and hopefully you can see that. This is your adjusting assembly. You'll notice there's no cable or lever or anything like that from the self-adjusting assembly that drum brake cars used to have. These do not self-adjust, which is one of the reasons they need to be serviced. Of course, then on the back side you've got your slot for your adjusting tool. As far as the magnet itself goes, this one's in really good condition. It's about like brand new. They'll start to wear it kind of a little bit of a slant, which is normal. If you start seeing where they've rounded off a corner, that's bad. Sometimes you'll see where the assembly here has come off. You might find the magnet kind of floating around in there, detached from the arm. Of course, that caused the brakes not to work. As far as electrical problems with the magnet goes, I found that's fairly not very common. And if you take an ohm meter across the two wires for the magnet, I'd expect you'd get a handful of ohms, like 4 or 6 ohms, somewhere in that range. And also take a continuity test between each wire and the metal housing of the magnet, and there should be no continuity. Generally, if it fails, it's either going to be a direct short where you're going to get no resistance, or it'll be an open circuit where there's no continuity whatsoever. Of course, either of those cases, you'd replace the magnet. Brake lining material, depending on your model, there'll be a spec of how much is still serviceable. If one of these is burned up or low on material or whatever, a lot of times you can just buy this whole complete assembly and not have to deal with taking the shoes and levers and all that apart. Just unbolt it from the axle and clip the wires and install your new one and rewire it up, and of course then end up adjusting it. And that way you get all new hardware, and it saves you a whole lot of time. Even if you were to replace, say, the shoes, the pivots and whatnot may be worn, or the springs might be getting loose. A word on the connection for the electrical part of this. There's no polarity. Basically, either wire can be hooked to either wire on the trailer's wiring. I would use the really nice crimp connectors that have the heat shrink seals on them. I think 3M makes them. You don't want corrosion, anything like that, giving you a bad circuit. For sure, don't use those little crimp-on clamp locks. And the other thing I'd mention, some trailers, the wiring on them is kind of a Romex looking thing, 2 conductors separately insulated within a sheath. And some of those have 2 layers of insulation on each wire. The inner layer of insulation is almost clear, kind of a translucent gray. And if you didn't know it was there, it would be really easy to think you'd strip the wire after you got that first layer off and didn't know that second layer was there. So, fray those wires a little with your finger just to make sure that you're actually down to the wire. So if you were to crimp connect over that second layer of insulation, of course you wouldn't get a good connection. So that's the brake back plate assembly and those parts. This is a pretty typical example of a light-duty drum and hub assembly with the outer races of the two wheel bearings installed. The armature surface is in pretty good shape. No big gouges in it. The drum surface is in good shape. Of course, you'd want to inspect it for cracks or heat damage or that sort of thing. It'll be marked with a maximum diameter for the drum. If it's worn beyond that, of course, it's garbage. If you get one that's really worn, it'll have a ridge around the outer edge, and in that case you may have to back the adjuster of the brake off in order to get the drum off. Anyway, you can see the outer race of the inner bearing here and the outer race of the outer bearing there. Those are a tight press fit into this drum. They're not normally removed unless you needed to replace them. I should comment, if you find a flaw in either wheel bearing or the race of either one, you'd replace the both exterior races and both sets of wheel bearings. You'd never want to run a new bearing in an old race. They wear into each other and you just end up with the thing failing. So that's kind of it from the trailer end. Let's work our way forward and kind of explain the rest of the brake system here. Okay, we're up at the front of this little bumper pull trailer, and wanted to point out a couple things. We've got a little box with a dry cell battery in it. It's required by DOT standard that you have a breakaway system that has to have a battery capable of operating the brakes. Typically these use the cheapest thing they can find, hence the little dry cell battery. Often in little bumper pull trailers like this, it'll be isolated with a diode and maybe a resistor from the interior lights of the pickup, or of the trailer rather, and the charging circuit of the pickup. Kind of limits how fast or how much current that battery will take to not charge it more rapidly than it can handle. Personally, I like to use a lead acid typical bigger battery or whatever, and I'll eliminate that circuit in there so it's directly connected to the truck's charging circuit with a fuse. Anyway, here's a breakaway switch, which is tethered to the truck there. In a nutshell, if you jerk that pin out, it just connects the positive side of this battery directly with the brake circuit. Of course, the one side of the brakes are going to the chassis ground, and the other side to the brake circuit. That goes by this breakaway switch, and also is connected to the pigtails. Brake circuit for the pickup. That's while we're looking at things. Fifth wheels and goosenecks are pretty much similar. Got a breakaway switch here mounted on the pin box, and same 7-pin RV style connector. In the case of this fifth wheel, since it has 12-volt house batteries, the safety switch is wired directly into that circuit. So if you were to jerk this out, it would apply straight full 12 volts to the brakes. You should probably note the breakaway switch is not a parking brake. It draws quite a bit of current from the batteries when it's activated, and the magnets aren't designed to be subjected to full power continuously like that. Also, some brake controllers on vehicles don't do well if they're back-fed electricity. In other words, if they get power supplied through to the brake circuit side of the controller from the trailer, they might cause damage. So that sort of brings us to brake controllers and pickups, or your tow vehicle. Generally, if a vehicle is equipped with a trailer tow package from the factory, under the dash here you'll have a 4-prong connector, usually tucked up under the parking brake, something like that. It supplies a negative lead, basically a ground lead, negative lead, 12 volt power. It will supply a feed off the brake light switch that's hot when the brake light is activated, and the last wire would be the wire that runs back to the trailer plug and goes to the brake circuit of the trailer. There's essentially 3 types of brake controllers. Let's back up a minute. Back before proportioning valves and anti-lock brakes, a lot of brake controllers for your trailer had basically a piston and a spring, so that the pressure brake fluid acted against the spring and actually physically moved a knob back and forth as you applied the brakes. And those actually worked pretty good as far as being smooth and powerful and easy to adjust, but they displace brake fluid, so when they put in proportioning valves, if you ended up having the front or rear of the vehicle's brake system developing pressure before the other circuit, it would cut off the supply of brake fluid to the circuit that didn't build pressure, kind of a leak protection sort of thing, and it would turn on a warning light. So that kind of brake controller wasn't compatible with that. So to kind of work around that in ways to apply current to the trailer brake somewhat proportionate to what you're doing braking with the pickup, there's what they call a timer based controller, or a non-proportional controller. Essentially it has 2 adjustments. One is a curve of how fast the brake current will ramp up from when the brake light switch is activated, and the other one is the maximum current that it would be allowed to reach. And those are the only inputs that type of brake controller uses. So in other words, you might set the maximum current somewhere less than what would lock up and skid the trailer at low speeds, and the how fast it ramps up to something that's not too abrupt. Those things are really horrible, and I'd basically encourage everybody to avoid using something like that. The problem is, as you're driving in town and you're easing up to a stoplight or stop sign and the car in front of you goes and you ease off the brake, it applies the same amount of braking then as it would if you were driving on the freeway and slammed on the brakes, assuming you didn't adjust it in the meantime. So it really gives you the feeling of the trailer trying to jerk the pickup to a stop when you're driving at low speeds, and gives you the impression that the trailer is going to push the truck sideways, or that you're not getting much for trailer braking at high speed, like if you had to slam on the brakes for a deer on the freeway. Basically, they're the cheapest and easiest way to meet the legal requirements of having brakes on your trailer. So a second type is an accelerational sensing brake control. Some of them are electronic, solid state. Some of them used a pendulum. A little bit better in that when you applied the vehicle's brake, that activated the controller via the brake light switch, and it would apply an initial constant, a fairly low amount of power to the trailer brake, and it would ramp that up based on how quickly it was sensing the tow vehicle decelerating. So it's kind of proportional to, it's kind of gives you more braking if you slam on the brakes in a panic stop, and less braking if you ease up on the brake like around town. Technosha Prodigy and P3 are probably the nicest controllers of that type, and they're perfectly fine and safe and all that sort of thing. The controller that I've got in here is a little different. It's basically directly proportional to the fluid pressure in the brake system, kind of going back to the way the old controllers work. And the reason it's compatible with anti-lock brakes and so forth is that it uses a solid state pressure transducer that does not displace any fluid, so therefore it doesn't affect the anti-lock and proportioning system. So you can see I hit the brake pedal and that activated it, and the more I stomp on the brake, the more it ramps up or ramps down the level of trailer braking. So this is a Brake Smart unit, another controller that operates on that same principle as Max Brake. Both are expensive, both take a little bit longer to install, but I've got to say this thing is absolutely amazing. The trailer brakes basically work so seamlessly with the pickup. It's like, well, like the way the front brake of a pickup that's not towing works with the rear brake. You don't really notice them fighting each other or anything, it just stops. That's how this works with a trailer. I guess while we're at it, maybe I'll pop the hood here. And here you can see right here is that pressure transducer. It's just a T between the master cylinder and the brake line there, and transducer screwed into it, connector for the pressure sensor, and it's just run through the firewall up to the brake controller. Pretty easy to do. It doesn't require fully bleeding the brake system. Basically you can put that, clean everything up so you don't contaminate everything. Unhook the one line from the brake controller. Of course, use a rag, that brake fluid eats paint. Put the T in there, reinstall that line. Be very careful not to cross thread anything. It's really easy to do with brake lines. Get them tight, screw the sensor in there, put a rag around it, have somebody press on the brake controller, or the brake pedal rather. Back out the sensor a little bit until you get fluid flowing around those threads with no air bubbles, and then tighten it up. Since it's at the top part of the system, when you've opened it there, no air ends up going down. So anyway, fairly quick and easy to install. The other thing I'd mention with brake controllers, I mentioned there's a if you've got a vehicle with a tow package, you end up with a 4-prong connector there, and usually the vehicle will come with the mating connector so that you can attach that to your choice of brake control. And then the brake control, of course, comes with a group of 4 wires sticking out of the back. Those may be various colors, but do not connect them color to color. Depending on what brand of brake controller and what brand of vehicle, that might not be correct. Make sure that you've got your positive feed to your brake controller's positive feed, the negative to the negative, the trailer brake circuit to the trailer brake circuit, and so on. In other words, connect them by function. A lot of brake controllers on the market can also be ordered for a specific vehicle. In other words, if you bought a Ford compatible brake controller, it would come with a pigtail correctly wired that would plug into the connection under the dash. Oh, speaking of Fords, vehicles differ in whether or not the charging plug at the back of the vehicle is hot all the time. On the Dodge here, it is. Basically the battery, breakaway battery charging circuit or the RV charging circuit is on, whether the engine's running or not. On Fords, that pin is live when the engine's running, but only if you install a relay into the fuse panel. So if you look that up in your owner's manual, it's a real common relay. Any auto parts store would have it. They're like 12 bucks, something like that. You need to install that. Obviously, if the trailer's breakaway battery doesn't get a charge from someplace, it's not going to stay charged, and then it wouldn't stop your trailer in the event you had a hitch fail.